Hey guys, it's Rusev here. I wanted to make a video to go over the latest JRealm release, 0.2.6, which came out 2 days ago. I wanted to go over the changelog, do a small play demo, and talk about some of the architecture, which I had talked about doing in the last video, and I think this is a good time to start doing it. So I've made a nice architecture diagram, and we're going to go over a few of the bits of the code that make this whole project work, right? And just a disclaimer, I am in no way a professional game developer. This is my first real big project, and I don't typically work on stuff like this, so take everything I'm saying with a grain of salt. This is going to be meant, for a medium technical level, so I'm going to assume there's some networking and, general coding and a general idea of how a game is put together, right? But in no way are you going to need to know, language specifics or anything like that. So let's go ahead and dive into it. The focus of the latest release was to address issues that I uncovered in the previous release while load testing. I found that after a certain amount of players would get on, that the server would not be able to transmit all their data within the rate I wanted. And this was primarily due to oversending data, right? So in the case where I had moved the player far enough away from a bullet or an enemy, the server would still be transmitting movement and update data for that object, which adds a lot to the bandwidth usage and essentially would constrict when there's many entities on the screen. So because of that, I implemented viewport culling for just about everything that goes on in the main tick loop, the main broadcast loop. So only entities within a certain rectangular area around the center player are going to be rendered and transmitted to the client. That allowed me to get a lot more players on the server and fit a lot more entities on the client's viewport while they're moving around and interacting with the game world. So that is a great change that helps performance, and it makes it a lot more stable, a lot more crisp movement. We're not getting movement artifacts and glitchy stuff moving all over. So great change there. Next thing we did was add optimistic client movement. Previously, we were just waiting for the server to update the client's position. So now we're going to be sending the move packet to the server and then moving the player on the client side in line with that. So it makes it a lot more crisp, even though the actual hit rendering and collision detection are still performed on the server. So it just allows a little more clean and crisp movement, or perceived movement, rather. And the next change we have is we've completely reworked the tile map system. So previously we were using TMX maps, which is an XML map structure that you can edit with something like tiled. And it's really great for a basic implementation of tile maps. It allows you to create, split up an image into sprite sheets a sprite sheet and then put those sprites in a tiled map to be rendered. So I wanted to add a separation between the tile definitions themselves and the actual maps themselves. So I've split that up into two pieces. We've now got a tiles JSON structure as well as the maps JSON structure, which we'll go into a little bit when we do the actual demo here in a sec. And so because of that, I've had to migrate the existing maps over. So that's still in progress. We've only got one map right now, which is sort of just a Vault demo map. And the last thing is I've just cleaned up a lot of the code, removed some unneeded assets. So the game binaries themselves are still very small. Of course, they're still combined into the client and server. They're really, it's just the run parameters. They're different, but still pretty small. So working to keep that down. And with that, let's go ahead and get into the actual play demo. So we're going to do two, right? We're going to spawn some headless players that we can look at and interact with. And first we're going to just run the local server with one player, just me. So, this is the Vault map that I've got. It's very simple. Red Abyss of Demons wall with some yellow grass. And you can already see the implementation of the viewport culling happening, right? You see the objects popping in and out of my render viewport. Still needs a little bit of work in terms of the distance, right? You can see bullets are coming off the screen, which it's not the best experience, but right there, I think that's a good demonstration of exactly what's happening, right? So the server, as I'm moving around, he's keeping track of this rectangular area around me, And when that rectangular area overlaps with a entity on the server, it's going to tell the client, it's going to send in a load packet that entity's data, right? So that happens once, and once that entity's ID is on the client, it's able to receive movement packets for that and all its bullets, which are then rendered as bullets, obviously, and then the moving entity on the client side. So that allowed me to decrease the bandwidth consumption of the client, and it allows a lot more bullets to be on the screen at once, and also a lot more players to be on the screen at once, right? Because an individual player could be all the way over here taking damage from enemies that I don't even know about, and that's not going to take up any bandwidth usage on my end. And that was previously an issue because become very inundated with data when there's tons of bullets on the screen. So that's it for the single player demo. We'll just add like 4 enemies right here. These are going to be headless players, so they're not going to be receiving data, right? Because they're not actual clients connected, but they will be thrown into the ticking loop of the server, so they will get shot at. The enemies will chase them, and I will be able to see them, right? So they're obviously cold as well, so when they move out of range for me, I will no longer see them. Right, as you can see, he's already dead. So as you can see, that player down there is getting shot at. Yeah, there's still some issues. There seems to be a way where the he doesn't get detected to be unloaded, but that's fine, right? Just little improvements to be made here. And I've tested this with up to 10 players. It's pretty performant. We'll look at the read rate here in a sec to confirm that. So that's about it in terms of the actual changes in the demo. So we'll go ahead and exit out of here. All right, so our read rate with those 3 players is around 186, which in kilobits to kilobytes, it's about 23 kilobytes, which is very reasonable for any modern internet connection. So we'll go ahead and take a look now at the changes to maps and tiles, which I mentioned over on the releases. This is the split I was talking about. We now have a JSON definition for every tile that is going to be in the game, as well as the maps themselves. So the tile data simply stores the name of the tile, its sprite key, right? The image it's going to be loaded from, its row index and its column index, and then the size to render it at. There's also some tile data, which I mentioned is going to be important. This is a pretty sparse implementation right now, which I'm going to be able to expand in the future, right? So has collision, slows, and damaging are 3 effects that can currently be applied to a tile. So what we're going to assemble these tile IDs into is a double array of layer data, which is very similar to the TMX maps that I mentioned previously, except it's a little more easy to read because it's in JSON. And I actually am currently working with one of my software developer friends to get this, get an editing program similar to tile built that can work on these double arrays in a little more visual way. It's going to make it a lot faster to build maps, and a lot easier to do stuff with them and not have to edit them like this, because we can see on this the collision layer, it gets pretty ugly when we start adding in void tiles and actual collision tiles. It can get pretty ugly. You can see that there. So don't want to have to worry about that. But that's it for the tile changes, right? That's a forward-looking change for dungeons, dynamic terrain loading, and having that be just a more stable process. I didn't feel good about the current implementation, so I had to work on that. So the last thing I want to go over in this video is the overall architecture of JRealm, right? So what I have here is a depiction of a 2-client connection to the server. Right, we're using just a TCP connection with a custom packet protocol that I worked on myself. It's pretty basic, right? Packet ID, packet length, and then packet data, right? Very, 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 very straightforward. So what we've got here is essentially the overall networking loop that we're going to be participating in when we connect in as a client, right? What we're going to do is we're going to send a login packet to the server, And what that's going to do when we connect here is it's going to spin off a processing thread, right? Each client that's connected to the server gets its own processing thread, which is going to be responsible for reading bytes transmitted over the net into its buffer and then deserializing those into packets, right? Those packets are going to be stored in a queue, and every game tick, the server is going to dequeue all those packets, and for each packet dequeued, it's going to run a callback with that packet. That's going to do a couple things. That's either, going to be for something like chat, which, we're going to send a chat message to the server. That's going to, in the packet handler for all of the clients connected, go send that packet back to them. So they get a copy of the chat message, right? In the case where we are just ticking the game state, right? Every time there is a tick and the delta has changed on the server state for the client, it's going to send a message to all of the clients connected, right? So if an enemy is spawned and it's in these two clients' viewports, it's going to transmit that enemy's data in a load packet to each client, which is then going to put it in its realm state and allow for each subsequent tick to send movement data, death data. It'll be unloaded eventually, but that is the core responsibility of the server, right? We're going to have all of these realm states here, and we need to keep them up to date with the realm state here, right? This is the master copy. It is server authoritative. So the client's job is essentially just to be an observer to this and request changes to it, right? So let's look at the scenario where we're going to do a move item, right? So let's say I want to swap inventory slot 1 with my equipment slot 1. I'm going to just send those indices to the server. It's going to be processed by my processing thread, and I'm going to then look at the player's inventory data in the server's realm, see if I can perform a swap operation, and then the next tick, that is going to be reflected in my client. So it's just a big looping process where we are receiving tick data or reacting to a event message received in the form of a packet. So login is that an example of that. The chat broadcasting is another example of that. And that's how I like to think about it. It probably needs a lot more work and is probably incorrect in some ways, but I think a lot of the core concepts are there. So I wanted to just share this with you guys and, make you aware that you don't need, a ton of industry specific knowledge to put together something like this. I've really enjoyed the project so far. It's been fun. I'll probably make the code public at some point in the future, but for now, this is going to be private. So, feel free to leave any comments with stuff you'd like me to go over next. I appreciate you guys taking the time to listen to this. And if you want to subscribe for, to follow along the journey, I'd greatly appreciate that. I'd love to interact with some people, who are in the same stage of game development as me. It's always fun. But thanks again for taking the time to listen, and I'll see you guys in the next one.